I'm going to be talking about absolute value inequalities. And these are very similar to absolute value equalities, as we have two answers. And we usually can split it into two equations, positive and negative. So we're going to keep that in mind when we're writing these. Okay. Now, first off, I have kind of a hint of how to write these inequalities. We have great or and less than. And so what this is going to look like is if we have the absolute value of x is greater than 5, that's a greater than symbol. And since it's great or, we can write this as an or compound inequality. And when we have an or compound inequality, we split these into two different inequalities. So we can write x is greater than 5, or x is less than negative 5. Okay? And of course, the second one's going to be a negative, and when we have a negative and an inequality, we flip the sign. And we always write it in order, so we can say x is less than negative 5, or x is greater than 5. And that's going to be our answer for that one. Now, if we have a less than, it's going to be an and compound inequality. So let's do absolute value of x is less than or equal to 5. So this is a less than, we're going to write it as an and. And x is always in the middle when we write an and compound inequality. So we're going to have x is less than or equal to 5. And then we can put a negative 5 at the other end. And we have our solution for our and. So that's going to help us write our compound inequalities from our absolute value. All right, so let's try this one out. Number 1, absolute value of h minus 5 is less than or equal to 10. So since it's a less than, it's an and. So we can write this as h minus 5 is less than or equal to 10, and we can put negative 10 on the other side. Now we can solve this inequality. We add the 5. So we have a negative 5 is less than or equal to h, which is less than or equal to 15. And now we can graph this, because it says graph the solution if possible. So we have a negative 5, and we have a 15, and since it's less than or equal to, we fill in our circle. And then since it's an and, we shade in the middle. Now our next one is absolute value of 4c plus 5 is greater than 7. So this is going to be an or. So we're going to split this into two different inequalities. So we're going to do 4c plus 5 is greater than 7, or 4c plus 5 is less than negative 7. And now we're going to solve this. We subtract our 5 on both sides. We have 4c is greater than 2, divide by 4, and we get c is greater than 1/2. The next one we're going to subtract by 5. We get 4c is less than negative 12. Divide by 4. So c is less than negative 3. And now we can write this in the correct order from least to greatest. So c is less than negative 3, or c is greater than 1/2. And we can graph this now. We have a negative 3. We have a 1/2. Since it's just great or, we have an open circle. And we shade them in opposite directions. Okay. Let's try some more examples. Now remember, when we have an absolute value, we always have to get it isolated. We have to get it alone before we can split it into two different inequalities. So for number 1, absolute value of 3j minus 1 plus 6 is greater than 0. We have to subtract the 6. So let's subtract that on both sides. So the absolute value of 3j minus 1 is greater than negative 6. Now we have to be really careful when we see a negative. Now remember, absolute value always has to be a positive number. So if we put any number, positive or negative at all, it will always come out to be positive. And a positive number is always greater than a negative number. So in this case, we don't even have to write an inequality, because we know that it will always be greater than. So this one is going to be all real numbers. Okay. Now number 2, we have a negative 4 times the absolute value of 6b minus 8 is less than or equal to 12. Well, we've got to isolate first before we do anything. And remember, when we divide by a negative, we have to flip the inequality symbol. So now we have the absolute value of 6b minus 8 is greater than or equal to negative 3. Once again, will an absolute value always be greater than a negative? Yes. So once again, we have all real numbers. So we have to be really careful when we get negative numbers. Now, if it was less than, it would be no solution because an absolute value will never be less than a negative number. All right, let's do a word problem. So this is about absolute deviation. And if you look in the red to the right, it says you can write the equation by using the absolute deviation equals the absolute value of x minus the given value. So let's read this. It says you are buying a new computer. The table shows the prices of computers in a store advertisement. You are willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your condition? Now there's a couple of things here that it's going to help us. First of all, you're willing to pay the mean price. Mean is average. So we're going to find the average of these computer prices. And to find the average, we're going to add all of these up, okay? And I've already done this. So if we add all of these up, we get 6,640. And since there's 10 of them, we're going to divide by 10. So the mean price is 664, okay? And this is going to be your given value. And then I tell you the absolute deviation is at most $100. So $100 is our absolute deviation. So now we can write an equation with these two pieces of information, okay? And so we're going to have the absolute deviation. We're going to use the absolute deviation and the given value. No, it says it at most. So we're going to say x minus 664 because that's your given value. And you're not willing to pay more than $100, so we're going to have this as being less than or equal to $100. Since it's less than, this is going to be an and. So we can write this equation as negative 100 is less than or equal to x minus 664, which is less than or equal to 100. And now we can solve. We're going to add our 664. And our solution is going to be 564 is less than or equal to x, which is less than or equal to 764. So what you're willing to pay is between 564 and 764. So let's see the prices. Let's circle the prices that fall in between there. 750 falls in between there. 650, 660 is in between there, 670, 650, and 725. So these are the prices that you're willing to pay within that absolute deviation of the mean price.